Section 1.4, perimeter and area in the coordinate plane. So you need to know the vocabulary words for different sided shapes. So a shape with 3 sides is a triangle. You likely know that one. Then it goes quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, undecagon, dodecagon, and anything more than 12, say 13, you would say 13gon. 14 is a 14gon, 15, 15gon, and so on. So in this class, I'm going to say things like an octagon, and you need to know that octagon means 8. So octa, the beginning of octagon, like an octopus, has 8 tentacles. Pentagon may be a pentagram. You've seen that. Quad means 4. Nonagon, I remember because N is 9. Decagon, a decade, has 10. Deca means 10. Hexagon and heptagon are a little tricky to remember. A lot of students get those mixed up. The hexagon has an X, just like the word 6 has an X. Heptagon does not. So, some more vocab. A polygon, it's a figure with straight line segments on each side that don't overlap with one another. They just cross at the corners. So, an example, maybe something like this. This has 5 sides, so this would be called a pentagon. The flat parts here, those are called the sides. And the points, or the corners, that's a vertex. Each one of those is a vertex. It has 5 vertices. So 1 vertex, 2 vertices. This is a polygon. Now, example of something that's not a polygon, this. This is not a polygon because it's open. Another example of not a polygon, say the letter D. This one is now closed. It starts and stops in the same place, but the curved part of this makes it not a polygon. Another one. Here maybe. This one is not a is not a polygon because your lines cross. So they can't cross. You have to start and stop in the same place, and you can't have any curves. The diagonal of a polygon. So we have 2 words here. We have convex and we have concave. To me, a concave polygon is the easiest one to draw. It's one where your polygon actually caves inward at some point in time. So if I were to draw a pentagon like this, 1, 2, 3, 4, 5 sides, the cave is right there. That's where it goes inward. So maybe another one, 1, 2, 3, 4, 5, 6. A hexagon, 6 sides, the cave is right there. So the cave is where it's going inward instead of outward. A polygon is either concave or convex. So the convex ones will be the ones without those little cave spots. So let's see here, maybe this, a square. This is a convex shape. A concave quadrilateral would look more like that. This is convex quadrilateral. This is concave quadrilateral. The diagonals connect one vertex to another vertex, but you don't want to use, see, the top 2 are already connected. The left 2 are already connected. The only one that needs connected now is through the middle there and through the middle there. All other vertices have already been connected. For a pentagon, which ones are not already connected? Well, the top is already connected to the right, the top is already connected to the left, but it's not connected to the bottom right, and it's not connected to the bottom left. So those are 2 diagonals. Let's see here. The left one is already connected to the top. It's already connected to the bottom. It's not connected to the right side, and it's not connected to the bottom right. The right side is already connected to the top. It's already connected to the bottom. It's already connected to the left already. We only need this one here. And now this bottom left corner is already connected to all of them. These in the inside that make the star, those are your diagonals, the ones going through the middle. Perimeter. These next couple of formulas are ones that you've probably learned before, maybe in middle school math somewhere. Perimeter is the sum of the outside numbers. So if you have, let's say, a triangle, and this was a 3, this was a 4, and this was a 5, the perimeter is the sum of the outside. 3 plus 4 plus 5, 12. It's the outside part. How far would you have to walk to get around the shape? So in a triangle, officially naming a triangle, if we have a triangle, it has 3 vertices. Vertices are points, so they get letters. Let's say A, B, C. They cannot be in a straight line. If A, B, and C are in a straight line, then you just get a line. It's not a triangle, so they have to actually make a triangle. And this triangle we would call triangle A, B, C. Now if you wanted, you could also call it triangle CAB, or triangle BCA, or triangle BAC. You can put them in whatever order you want for a triangle. But this symbol right here is necessary. That's the symbol for triangle. For a triangle formula, the perimeter is A plus B plus C. So in that situation, A, B, and C are on the sides of the triangle, the 3 sides. You would add those up. And the other formula for a triangle is A equals 1/2 BH. That's where likely B stands for base, that's the bottom of the triangle, and your H is the height. It's going to be going straight up. Sometimes it looks like this, base and height. Height goes straight up. A few things to know. P stands for perimeter, that's the outside. A stands for area. For square, the formula for perimeter is 4 times S, where S is the length of the side. Now for a square, all 4 sides are the same. So you could, for the perimeter, do S plus S plus S plus S, add up all 4 sides. But if you take something and add it 4 times, you might as well just multiply by 4. To get the area, it's S times S. I also personally use A equals BH, where B is the base and H is the height. In the case of a square, the base and the height are the same, so you're just multiplying one of those numbers by itself. For rectangle, perimeter is 2L plus 2W. 2 times this plus 2 times this. You can also just add up the 4 sides. Length plus width plus length plus width is 2L plus 2W. Area equals length times width. Again, I personally like A equals BH, base times height, where the base is the bottom and the H is the height. Now the reason I like this better is because I even paused here. How do you measure the width? Well, If I asked you to measure the width of your paper, I would measure from the left to the right. If I asked you to measure the length, I might also measure the left to the right. So for me personally, I get confused about which one's the length and which one's the width, and it's a silly little thing to confuse me, which is why I prefer base and height. Base is at the bottom because the base is at the bottom, and height goes up because that's what height means. So I prefer BH, and that's probably the one I will use in class. So example 1, classify each polygon by the number of sides and tell whether it's convex or concave. Alright, so classify. It's a weird way to say the directions, but they're asking you to name it. So the names on the front side, the triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, undecagon, dodecagon, or n-gon, they're asking you to name these shapes. So count the number of sides. 1, 2, 3, 4, 5 sides. This, number 1, is a pentagon. Then, is it concave or convex? Does it go in anywhere instead of out? Right here, it's concave. Number 2, how many sides does it have? 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. Octagon. Does it go in anywhere instead of out? Are there any cave-ins in this shape? There aren't. It's kind of more circular shaped. This is convex. Number 3. Now, the most missed thing here is people counting incorrectly, so count carefully. I personally like to mark where I start, so I know when I've made it around the shape. So I'll start here. 1, 2, 3, 4, 5, 6, 7, 8. This is another octagon. This one, though, actually has a cave-in right here. If you look, it's basically the same shape, except this top left corner was moved to the inside of the shape. This one is concave. Number 3. Number 4, again, I'm going to start here. I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dodecagon. And this one, no cave-ins, so we call it convex. Example 2. Find the perimeter and area of the polygon with the following vertices. So let's see here. We need maybe an X and a Y axis. There we go. And let's plot some points. So X is at -2, 4. That means left 2, up 4. Left 2, up 4. Put a dot, put an X. 0, -2. That means you don't go left or right at all, but you go down 2. That's Y, so you label it Y. And Z is at 2, -2. Right 2, down 2, Z. And here, I plotted 2, 4 wrong. X is not there. 2, 4 is right 2, up 4. There we go. Connect the dots. And the shape we get? 3 points that we're connecting, it's a triangle. So let's do the area first. Area equals 1/2 base height. This is the one I prefer to make the language a little clearer. So the base is at the bottom. How long is the bottom side of the triangle? Well, here's the bottom. From Y to Z, you count. How many squares long is it? 2. So 1/2 times 2 times the height. How tall is this triangle? Count the right side and see how tall it is. 1, 2, 3, 4, 5, 6. 1/2 times 2 times 6 is 6. Now the perimeter is a little more complicated here because the perimeter is where you add up the 3 sides. Well, we know the bottom is 2. We know the right is 6. But we don't know from y to x. We don't know that length. We don't know the distance from y to x. So oftentimes in math class, what I say is that you don't always get what you want. But if you try, you can find what you need. We can find this length using the distance formula from a previous section. The distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. We actually have to calculate that third side. So let's see here. We're using x and we're using y. So let's make this x1, y1, x2, y2, and plug in the formula. x2 minus x1. 0 minus 2 squared plus y2 minus y1, negative 2 minus 4 squared. Order of operations, 0 minus 2, negative 2 squared, plus negative 2 minus 4, is negative 6 squared. Make sure here that you know how to subtract positive and negative numbers. If you're unsure, make sure you're double checking on a calculator. Negative 2 times negative 2 is 4. Negative 6 times negative 6 is 36. This is the square root of 40. And then you need to type it into your calculator. The square root of 40 is approximately 6.3. So the left side of that triangle is approximately 6.3 units long. So all that just to get the third side so we can add them up. The perimeter, add up all 3 sides. 2 plus 6 plus 6.3 is 14.3. Now, all of this is required. Even once you get to 6.3, don't just type this into your calculator. Make sure you write it down so I know what you're adding, just in case you add incorrectly and get a wrong answer. Last one, example 3. Find the perimeter and area of the polygon with the following vertices, J, K, L, and M. So J, let's get some axes here. The X and the Y axis. J is negative 4, 1. That means left 4, up 1. With the J. K is negative 4, negative 2. That means left 4, down 2. L is 3, negative 2. That means right 3, down 2. And M is 3, 1. So that means right 3, up 1. We're going to do a lot of point plotting points just like this in this class. If you're having trouble plotting them correctly and quickly, it might be worth you doing a little bit of research online and practicing some Algebra 1 skills for plotting these points. So here's our rectangle. Let's do area. For a rectangle, area equals base times height. How long is the bottom? Count. 1, 2, 3, 4, 5, 6, 7. How tall is it? Count. 1, 2, 3. 7 times 3, 21. The perimeter technically is 2 times the length plus 2 times the width. I personally would probably just do 7 plus 3 plus 7 plus 3. However, to make it a little bit faster, maybe you could do 2 times 7 plus 2 times 3. 2 times the base plus 2 times the height. That's 14 plus 6. The perimeter is 20. And with this, you should have enough information to do the assignment for 1.4. If you find yourself needing graph paper, you can always Google or look up on the internet for free graph paper and then print it.